Hello viewers, question 2. A ball of mass 1.2 kilograms is dropped from a cliff 30 metres high. So the first task is to find the gravitational potential energy of the ball. So the formula for that is the potential energy is mass times gravity times height. And the mass we're given to be 1.2 times gravity is 9.81. The height is 30 metres high, and if we calculate that we get 353.14 joules, 16. Okay, question B, after it has dropped 10 metres, so up it was 30 metres high, once it's dropped 10 metres it's still going to be 20 metres high, so EP is same formula, finding the gravitational potential energy again, so that's 1.2 times 9.81 times the height is now 20, and we get 235.44 joules. Okay, question C, what has happened to the rest of the energy? So it's been converted into kinetic energy. That's what happens when an object falls. All of the gravitational potential energy gets converted to kinetic energy. And how much of that kinetic energy is there? Well, it's the same as the amount of potential energy that's lost. So that amount of energy is 353.16 minus 235.44, and if we calculate that we get 117.72 joules. Okay, so we've worked out what's happened to that energy. Now question D, find the speed of the ball when it has dropped 10 metres. Okay, so we've found that it's all been converted into kinetic energy. Kinetic energy is 1/2 mv squared, and the amount of kinetic energy we've got there is 117.72 joules. We need to find V from that, so if we multiply that by 2, we get mv squared, so let's divide by m as well. We get V squared is 2 times the kinetic energy, which is 2 times 117.72, and we're dividing that by the mass, which is 1.2, so therefore V is going to be square root of that, so we get square root of 2 times 117.72 divided by 1.2, and we get 14 metres per second. Okay, question E, show your answer is consistent with what we get using the kinematic equations of motion. So we're looking for the final speed here. Initial speed was 0, acceleration is 9.81, and we also have that the displacement is 10 metres. So we're using V squared equals U squared plus 2AS, so therefore V is going to be square root of U squared plus 2AS, which is the square root of U is 0, plus 2 times 9.81 multiplied by S is 10, and if we calculate that we also get 14 metres per second. Question F, with what speed does the ball hit the ground? So when it hits the ground, all of that starting energy, the whole 353.16 joules, has all been converted into kinetic energy. So at that point, the kinetic energy, half mv squared, is 353.16 joules. And then from there, we're going to do exactly what we did in question D. So we're going to multiply by 2 to get rid of that half, and divide by m, so we get V squared is 2 times 353.16 divided by the mass, which is 1.2. And if we take the square root, we get v is square root of 2 times 353.16 divided by 1.2, and we get 24.3 meters per second. And then we also need to verify that this is consistent with the kinematic equations of motion. So we've got v equals, we want to find that out. U is still 0. A is 9.81, and S is now 30. So just as before, v is the square root of u squared plus 2as, which is the square root of 0 squared plus 2 times 9.81 times 30, and if we calculate that, we also get 24.3 meters per second. Okay, thanks for watching. Over and out.